didn't even do all the homework, but I did some of the homework, and I understood the first few problems, but then I got into like the second part where it was like 35 through 61 odd, and I got like, I think I got 35, that one was good. I got 23, but I didn't really know why I got 23.
Did he have you guys do number 1?
No.
Okay, good. That's the only ones I would ever do, just in case he called on me.
I did 35, and I got it. I did 37, and I got that. But then I got to 39, and it went downhill from there. I only did 3 more, and I didn't get any of them.
You want to see how swollen my leg was?
Yeah. Oh my god.
I was like, Mom, this doesn't look right. And she's like, oh my goodness, Samantha. I was like, I'm not going to have your knees when I get older, am I? Because my mom played a lot of sports, and she tore up her knees to the point where she has constant knee pain now, but her next step is getting an entire kneecap replacement.
Ouch.
She has bolts and screws holding her together. Yeah. And then all my aunts have some kind of knee problem. I'm probably gonna have knee problems.
It's like, you know what? I just won't move my whole life.
I was like, see, Mom, this is exactly why sports and athletic stuff is bad for you.
That's right.
And she said, sports are, but I don't know about being athletic. You gotta get exercise and learning. I wasn't getting hurt until I started walking down the stairs. Walking is exercise.
What do you know about the hot-up-a-thon that we're doing on Friday?
Everyone has to do it.
You have something this Friday?
Yeah.
Yeah, the Phoenix Friday. We've got...
I didn't think that was a scheduled one. Veterans Day, something or other.
Yeah, we're taking a
NHS
Veterans
induction. And then this Friday? Yeah.
Come on, let's see if that was actually scheduled.
And then we have that hot lapathon, and right after the hot lapathon, you guys are gonna come up and do like a little mini field day for like the SGA is sponsoring it for since we always do something on Fridays and stuff. We typically do something. This year it's just, I mean, there's different stations. The Hungry Hippo, water cup relay, board games. There's a bingo station. Sally was insistent on doing bingo. She's so old. And the balloon game where you have a balloon and you run to the other side where there's a chair and you have to sit on the balloon and make it.
I have never played that game before.
I've never played it either, but they were like, oh yeah, that was so fun, let's do that. I was like, so.
And you don't have school next Friday?
Not to my knowledge.
Okay, so having the math meeting on Tuesday would be good.
Yeah, next Friday is Veterans Day.
At all?
We have school on Fridays anyway.
Oh, this is a Friday? I thought this was someday during the week. I was like, yeah, there's school.
And you don't have classes on Tuesday, except for this one.
Are we gonna have
Yeah.
high school classes though?
Don't have any high school classes?
Or for college?
Oh. Maybe.
What's
Where
tomorrow?
do you have that class when you take ACA 122?
I don't know. It's supposed to help seniors, but my thing is, it's already behind what I'm doing because I did early application for the college that I'm more likely to get into anyways.
I mean, didn't you learn all this?
So what I'll
It's just kind of varying depending on the school you go to. So writing
well, I'm actually finishing spring semester in.
wasn't helpful. I was just like, you know, I'm just gonna submit one I've already used for a scholarship because I don't need this. But everything was due either Monday or Wednesday. But they have the course set up really poorly because we actually have classes we have to do and applying to colleges. So none of us were like focusing in class. We were all doing stuff we actually needed to do. And now I'm like behind in my classes. I really don't like it. I see no purpose in it. You're gonna have to suffer through this next year, Chloe.
I'm not looking forward to it.
I think they're just trying to give everybody a class to kind of keep them at the high school. I don't feel like the fact that we're going away. And I think Miss Asher's also stopping the whole going to the Davidson campus thing. I like going to the Davidson
You
campus.
should fight for it.
I am. I'm gonna have a chat with her.
Because, I mean, eventually we'll have a new building to review,
I'm really sad I'm missing that.
but.
I'm really sad I'm not gonna be here with the new building. I wanna see it.
Well, next year, I'm gonna have to go to the Davidson campus for chemistry.
You're taking general history?
Yeah.
I'm sorry.
Thanks.
I'll save my notes
Thank you.
because he told us the best resource is find somebody who took his class and ask for their notes and tests and quizzes. And I did that with all the kids who took chemistry last year, and all of them were like, sorry, I threw them away, sorry, I burned them, and stuff like that.
If he tells you that notes are a good resource, then don't throw them away for the next class.
Right? So I will save them. So that
Can you save your Calc 2 notes as well?
I save all my notes just in case. I have this big drawer that I haven't opened.
I've got folders and notebooks and.
I mean, I know I'm not gonna keep track of this stuff, but I'm just to hoard all my stuff just in case
was 0 to infinity.
So down to 6 or 7 kids in here
I think it was rough because the thing because
I'll have it back.
no, I just want to remember exactly what it was.
now. Those next semester. I've heard that professor is mean and hard. Huh?
Okay, so simplify it down to 0, 1 times 6.
I have that
Pi
meeting.
times R squared.
Schedule's lining up. I wouldn't be able to take care of
What's
it.
6 pi r?
So I'm gonna take.
How would you not be able to?
Hey,
Because
thank you.
it's the day next semester, and I have 5 lab and chem lab to schedule right. Huh?
On the main campus?
Chemistry's on the main campus. And then I'll have bio lab, I don't know when. She just said one of my labs was during calculus.
What box?
2.
112?
Yeah.
Okay, yeah, me too. That's why I couldn't take calculus because on Monday, our lab is from 1:30 to 4:15. Which just hurts in itself. And then calculus would be at like 2. That's
Well, at least it's 4:15. Chem lab ends at 5. That's I still get a lab right after ours, so their lab starts at 5. Oh goodness.
just no.
I'm really going into chemistry though. I couldn't do chemistry.
Was accomplished. Just take it off and lose it. Yeah.
See, if I'm
With the little.
not gonna add another math. It looks like I'm gonna have a full schedule by the time of it.
It'll work.
2 chem, sure. Spanish 4, and then American 1. So
We
then
have 2 classes together.
if I have Calc 2, that's 5 times ready for college.
Yeah, no.
And ready for college, at that point, everyone's already applied for college, so they're making us read a book. Just supposed to get us familiar with stuff we'll see in college.
Sparknuts. Everybody's lost and I'm not reading either.
That one actually wasn't as bad as some of the stuff. If
I'm
you were
gonna
gonna,
finish it.
if you're gonna read anything in Britlit, A Modest Proposal, read that one.
Okay.
It is so good. It's really funny. I honestly thought the guy was being serious. But I was tired.
No, they're good.
And the funny thing, when I went to Ireland, our tour guide, Neve, she was like, raise your hand if any of you have read A Modest Proposal. And I was like,
That's it.
I think me and Miss Johnson were the only ones that raised their hand. I was
Very
like,
good.
"Wow."
That's right. Good job.
I'll say reference, but I read that one. It's also short. I read part of it.
Yeah.
During the first part of the semester, I was doing so great.
Yeah.
And I also read the Spark Notes so I could understand it. I don't know why. But
Slow
I just listened to the audiobook because my brain couldn't read that.
I just skimmed over the Spark Notes.
what for finish? Yeah, I'm gonna finish that later today. Before
Oh, yeah. Yes,
Freddie, did you do?
yeah. It's just a break.
But you didn't.
No.
Did you do the homework?
What?
Did you do the homework?
I didn't even touch
I love how at the point when no
Okay,
one's
fine,
doing
question.
homework anymore. I was on a roll at the beginning of the semester.
We have
and
so much faith in this.
So,
we're all doing terribly, but we're all not doing anything about it.
Yeah.
That's what I think is funny.
I got
I
there.
fell
and
down the
was
stairs
just
in my
like, I
house
have no
yesterday.
idea what I
Same
was
here.
doing.
Face first, and I hit my nose again, and it really hurt. It had a nice big bump right here. It hurts in my lip. You want to see my knee?
Right.
I took a hospital with it yesterday.
Sammy, what's your first class like?
It's from.
About my problem yesterday,
Yeah.
about another word problem you saw.
I didn't say that. Yeah.
I used one.
I've
Was,
asked
I just wasn't
More than I said.
my knee was.
Sammy,
And then I actually.
yeah.
I fell up the stairs. It was either up or
I watched this crazy series on BBC American. Dirt Champ.
up. So like,
Fred Douglas Adams, Hitchhiker's Guide to the Galaxy. Okay, it's another one of his books. It's a series.
okay, and she's like,
And talking about living the realm. So they have these two time stations where one is dirt usually in an hour time now, and the other is like kind of old.
And then they went somewhere.
But instead of swords, they have giant scissors.
So they're talking. They love the animal.
So they're
The one
defending
person
around
that
with
wanted to.
giant 6-foot scissors.
I got
Here,
it.
you got it right there. You got it right there.
I thought it was a concussion.
but it was.
Okay, so I guess it's about time. What I wanted to do first today is finish up the problem we were working on at the end of the period yesterday, and then maybe do another example and see what kind of questions you have on homework. Okay. So, try to speed along. I'm not going to do quite as much detail. I'm going to try to kind of get through this.
I mean, Sammy took this.
This was the equation I think we had yesterday. Patty shared this with me. I couldn't remember exactly the equation, but that looks like the equation we had yesterday created for minimizing the cost of materials in a can. And we even determined the domain to be 0 to infinity. Okay, so we got to that stage. We've created our equation. We've determined our domain. Now we just need to finish the problem, which is going to involve a derivative. So next thing we need to do is find the derivative so we can find the critical point. So help me quickly, how do I get the derivative of this? I'm going to take the derivative of that, which is going to be what? Times that, which is 0.52 pi times r, that's right. And then have to take the derivative of this. How do I do that? Yes. So it's minus 1.6 over r squared. Everyone else follow how we got that derivative? So the shortcut to remember is that this could be rewritten as 16r to the negative 1. Now if you do a power rule on that, you get negative 16, excuse me, not 16, 1.6. Negative 1.6 r to the negative 2, but the negative 2 can be the denominator. Okay, so now we get this, and we have to find our critical values. by saying it equals 0 and does not exist. So before I do that, I'm going to rewrite it so it has a common denominator of r squared. And so we'll have, yes, 0.52 r cubed minus 1.6 for r squared. Yeah, a common denominator making one fraction. Now I've got to set this derivative equal to 0 and also equal to, does not exist, find critical values. This is finding critical, what we've done before. So if I set that equal to 0, I get 0.52 r cubed minus 1.6 equals 0. Because the only way to make this fraction, the only way to make that fraction equal to 0 is to make the numerator equal to 0. And then to make that fraction equals does not exist, the only way that's going to happen is set the denominator to 0. So I get r equals 0 is a critical number. That's not even really in the domain. So I can eliminate this. 0 is not in my domain, so I can just throw it out. Now let's solve this one. What do I do there? 1.6 divided by cube root. Okay, yes. R equals 1.6 divided by 0.52 cube root, which is approximately equal to 1.45. 1.45. Okay, 1.45. So now what do we do with all that information? What's our objective again here? Oh, where did the pi go? Good question. Well, that's a back right there. That's a back right here. So that's going to be over pi right there. So that's going to change your answer. Good catch. I lost a pi somewhere. That means we won't have a happy Thanksgiving. We lost our pi.
Got him.
Good catch. I needed to keep up with all my parts of my problem. Catch. Well, I'll just clean this up a little bit. Well, we have a new number now. You know? Yeah, 0.99. Okay, go with that.
Great.
All right. Now are we good now with the get the pi back in place and everything? So what do we do next? We try to do what again, folks? Try to minimize this cost. Where do we find the minimal cost? At either critical value or
the beginning.
Check the critical value and the endpoints. So we're going to do all that. So we'll first look at our endpoints.
Okay.
Now, points are not endpoints this time. They're end of an interval, but they're not included. So the only way to handle them is look at limits. So limit r goes to 0 from the right of C of r. So what happens with my cost as radius goes to 0? What do you think? I'll write down there. I'll write it down here so that
Yes.
I'd like to get this reference, but then I can't see it on the camera, so I got to copy it down. So 0.26 pi r squared 1.6 over r. And so if r goes to positive infinity, r goes to 0 from the right, what's happening to this function? Zero plus 1.6 over 0 from the right is 0 plus infinity. That's exactly right. And what is 0 plus infinity? Infinity. You think that's going to be your minimum cost?
Yes.
That's your cost. That's your cost
Yeah.
at 0 radius.
Yep.
Why is the cost so high if you have a 0 radius? Because the thing is infinitely tall.
Whoa.
Okay, so limit r goes to infinity of c of r. Hopefully I don't have to recopy it. Let's just look at it from right above. What do you think's going to happen now? Infinity plus 0. Infinity plus 0, which is still infinity. Okay, once again, it ought to make sense. If the radius is infinite, then you got a lot of materials. That's infinite cost. Okay, good.
Yep.
Now let's look at the one that's going to be the minimal, because it's the only other option. We only got one critical value that's in the domain. So all we have to do is actually evaluate the cost at 0.99 inches of radius. What's the cost at 0.99 inches of radius?
How far you want to go? This one.
2.416.
It's a 317. Don't listen to him.
It's
417. Well, how many
That's a lot of
significant
cost.
figures?
That's kind of high. Because that's in dollars. So
Taken in this.
that means your soda just goes way up. Instead of a 6-pack for $2.41, each can costs $2.41 just for the material. So maybe our price per square inch might have been a little made up, like 25 cents per square inch is pretty expensive for aluminum. Okay.
Wow.
Anyways, there's how you handle the problem. Any questions on that? Anyone with us? Questions, Justin? Once I get this down, so. Okay, what was the question?
Okay,
You got it?
cancels out. That's the vehicle. Okay, never mind. I see what you
See it now?
Yeah, I got it.
Okay, good. Any other questions? David, do you have questions on this? Yes, Britt?
Can you go over another example?
All right, say it again.
Another example?
Another example. Yes, let's do another example. I was going to do a different type of example. Did you mean another example of this, or just another example of optimization?
What's another example of optimization?
Sure, let's do another example. That's a good idea. Okay, I guess I'm going to start over here, and I'll probably wrap right over there. Okay, so another example. This one is, again, a real-world example of having grown up in Florida, less than a mile from the beach. Used to spend a good bit of time at the beach. We won't talk about what we did during senior high school, but that was nothing. Anyways, lifeguards are a fact of life, and it's a good summertime job for high school students. And so here's a problem involving lifeguards.
What's it?
So
Lifeguards.
lifeguards, you've been to the beach, right? You've seen lifeguards sitting on their stands, and
Except
they
like towers.
they with their zinc oxide on their nose, and they watch you in the water. And they also don't get me wrong, but they also watch the sharks swim by you. And as long as the sharks are relatively small and there's not too many of them, they just let you go on and swim. Now, when they get big, then they start blowing the whistle. But you don't even realize how close the sharks are when they're swimming around. Not to scare you about the water. I was in high school and Jaws came out. Okay, so what are we gonna do here? So we have the shoreline here. There's the shoreline, and let's say that Susie is out in the water.
Is he flying?
Well, I don't know how to make water. She's flying above the water saying, "Help, get me back in the water."
Oh.
Let's make that Johnny. Johnny's the bad person. So all the Johnny that brought up.
Johnny.
Susie's going to be the lifeguard. So she's sitting on her lifeguard stand here by the shore. So here's Susie. Let's say that Johnny has swum out into the ocean. I don't know. How about 400 feet? And Susie is in a lifeguard station that's 600 feet from where Johnny is. So she sees him floundering and says, "Oh, I need to go rescue Johnny." She grabs her life ring and she goes running out like a la Baywatch or whatever you know. But what does she do? She has choice. She has basically three choices. She can either start and just dive right in the water like they do in Baywatch and start swimming vigorously towards Johnny, or she could run all the way to here and then swim to Johnny, or she could
Don't get straight. Put that
run part way and then swim to Johnny. It turns out that option 3 is the one that's taught and the professionals do. Why might that be? Well, you can run about, 12 miles per hour or something, and you can swim at best maybe 1 or 2 miles per hour. So swimming the entire way is the least efficient way to get there. And running all the way and then swimming out actually takes a little bit more time. The objective is to minimize time to get there and keep Johnny from drowning, so you run part way and then you dive in, and there's kind of a gut feel of how far that is. But we can use calculus to figure out exactly how far that is. So let's say that you can, I'm going to make up some numbers. I wish I would count. Let's say that if you're running at 12 miles per hour, how many feet per second is that? That's got to be around miles per hour divided by 5,000.
Just make it 1 mile away.
Okay, we'll say 10 feet per second. We'll go with that. So let's say you can run at 10 feet per second. If I had put it in miles per hour, what would you have to do, folks? You have to convert everything back. So I'm just going to convert it for you to save you a little bit of energy, I guess, at the same time. Well, let's say you can only swim at 3 feet per second. You got to swim into those waves. You're not going to go very far very fast. Okay, so how do we figure out where she has to dive into the ocean to start swimming? Well, our objective is we want to figure out the distance x, we call this distance right in here, x. How far from Johnny does she have to dive into the ocean and start swimming to minimize time? So our objective is minimize time. Our constraints are
His life.
are the picture shown, the distance is shown, so the picture and the speeds. And then we have to come up with some kind of a domain to go with that as well. Once we write our equation, we have to get an equation somewhere, somehow. Are we with us? What we're trying to do? Trying to save Johnny, so minimize time. Okay, so we got a picture, we got a graph, got some ideas of what we want to do, so we need to write an equation. So I'm going to move over here so I can write my equation. So, what am I trying to minimize again? So what does that mean in terms of writing an equation? For example, think back. We just minimized cost. What did that mean in terms of writing an equation? We had cost as a function of some other variable, right? So if we're going to minimize time, what does that mean? We need time as a function of some variable. Good, okay, so we need time as a function of some variable. I don't know what that's going to be yet, but I'm going to guess maybe it's a function of distance.
D.
I think that distance is a key factor in time to get there.
Mm-hmm.
And since the speeds were all given as a constant, what's the only variable in here? Distance. Y'all see that there's three different. I mean, there's a different distance depending on where you enter the ocean. I mean, the distance she has to go here is different than the distance if she went across and then straight up, and that's different than the distance if she went across and then went at an angle. Okay, so time as a function of distance is what we want. Time as a function of distance.
Mm-hmm.
Okay. Well, how do we measure this time? Well, clearly, time and distance and rate are how are they related?
Distance equals rate times time.
Distance equals rate times time. I agree with you. So therefore, time must equal
D over R.
distance over rate. I mean, right? Since we're allowing two different legs of her journey, a run and then a swim, let's build it that way. So we got to have the time it takes to run, and then the time it takes to swim. Okay, time to run. How far is she gonna? So we need to do time as distance divided by rate. So I'm focused on just the time to run, and I'm doing distance divided by rate. That's all I'm gonna do. It's that simple. Well, I'll do the rate first. Distance divided by rate. What's the rate while she's running? It says it's 10 feet per second. Okay. How far did she run? Yes, 600 minus x.
Dang,
Okay.
that's
So that tells me maybe my variable in my function ought not to be d. Maybe it ought to be x. So we'll just go back up here and call this in the general terms time. And then now we're going to do a time of x, because distance is being broken up into separate sections based on that x. So we'll use x as our variable. Okay? Let's do the time to swim. How fast does she swim?
3 feet per second.
Now, how far does she swim? Looking at the green picture, I don't know if y'all can see that. Let's go back over the green picture. Okay, well, let's copy it right here. I'm going to copy the picture right here. So this is what we've got going on. I'm just going to copy the picture. That was x. You told me this is 600 minus x. I agree with that. This was 400.
Oh, dang.
And this is her distance that we want right there. Distance to swim.
Smell?
So how might we figure out the distance to swim?
Oh, smell.
Pythagorean theorem is right. That's good. So the distance to swim is the square root of x squared plus 400 squared. All agree with that?
Yeah.
X squared plus 400 squared. Here we go, folks. We have our function. Time as a function of distance, but the distance is x, which is the requirement of where does she enter the ocean relative to where his position is.
Yes.
Any questions on deriving that equation? Okay, the next thing we need is a domain. Then we can do the derivative stuff. Let's do the domain. So what's our domain for this? Actually, this time it could be closed interval 0.
Whoa.
Okay, the question was, would I start with an open interval 0, like we've done in the past? And I'm going to argue on this case, x could be 0. What would that mean? If x was 0, that means she runs all the way to here, and then swims out. So x could, in fact, actually be 0 this time. So we want x to be an element of, and it could include 0 this time. What's the maximum x could be?
600.
600, because she could just dive in right here and start swimming. So
It's so funny. It's so funny to me. He's like, I'll save you. Stick the line this way. Yeah. Oh man.
okay, so now we have our function, and we want to minimize, and we have our domain. So what's next? Find critical values. How do we do that?
You gotta make the derivative.
Okay, so let's jump in on this derivative mess. Oh my gosh. The thing that they don't have to stop and do this is they're trying to save poor John. Poor John.
He's sitting there doing calculus.
Hang on, man. I need to get my. I need to do some calculus here in the sand before I go and rest.
See, Larry doesn't need calculus.
Okay, so what's the derivative, folks?
Well, you'd want to use the sum rule between them, but
Yes.
with those individual fractions, you're gonna do the quotient rule. But is there a way to cheat with negative exponents and use the product rule?
Certainly, there's a way to cheat with negative exponents and do the product, or not a product rule, but do a chain rule. But I wouldn't do a quotient rule here, folks. Why would I not want to do a quotient rule?
Would not.
Yeah, so if we don't see it, let's rewrite this. How about let's rewrite this as maybe 1/10 of 600 minus x. Oh, that won't be so bad now because 1/10 is just a constant multiple.
Oh, I dig it.
And 1/3 of x squared plus 400 squared to the 1/2 power. Now suddenly the derivatives don't look quite as scary as they did a moment ago.
That's good stuff. How do you get so good at it?
What is the derivative? Using the sum rule, as Rezo said. Start off with the sum rule and you go to the first term, and now what?
Do you do the constant multiple again? Is that just 0? Or do you
Not
move it
0.
up? 1/10.
I heard someone say, I think.
-1.
Well, yes, 1/10 times -1.
Yeah. Got him.
Now 1/3 times what?
We're gonna have to do a Hein here.
Yeah.
Oh.
Eventually, we're going to have to find critical values. I'm going to suggest maybe we try to do that. How do we do that? I might rewrite that. be, I don't know. Let's rewrite it. So this is negative 1/10. Here we've got the 2's cancel. 2's cancel. And so I have
1/3.
plus x over 3 square roots of x squared plus 400 squared. So now my derivative doesn't look quite as scary.
Yes.
I could probably combine those into like terms or something by making common denominators somehow. I don't know. So that might be, let's see, negative 3 times the square root of x squared plus 400 squared plus 10x over 30. Is that right? 30 square roots of x squared plus 400.
Yeah.
So far, so good?
Mm-hmm.
So now what do we got to do with this?
You gotta find critical points.
Find critical points. Okay, so we got to go through the game again one more time. So we got to set t prime equals 0. The only way that's going to be 0 is if the numerator is 0. So that would be 10x minus 3 radical x squared plus 400 squared equals 0. How in the world do you solve that?
Well, you add the 3 thing onto the other side.
Okay, we'll add the 3 thing onto the other side. It wasn't really so much that it was a 3 thing as it was a square root thing that we wanted to get on the other side. Why would we want to get that on the other side? Compare both sides?
Yeah.
So if we square both sides, 100x squared equals 9 times x squared plus 100 squared.
Oh yeah, why is it 100? Shouldn't it be 400?
There.
10 squared is
Oh.
only one.
Thank you. Yes, good catch, Renzo. That should be 400. Thank you. Okay.
Yeah.
91x squared equals 9 times 400 squared.
Hang on, what happened?
So x
What?
squared
He
equals
distracted.
You subtracted the 9x
Distribute the
squared.
9.
Oh, so we subtracted the 9x squared.
Yes.
I just don't do the skipping steps, man. You got me thinking about my ex. Oh,
Can't do it.
I'm just straight slow. That gone. Gotta increase my velocity.
Or technically can't even.
Yeah, I can.
91. See, that's fine. All on spots. Square root of 91. Okay.
I can dig it. Is that 1200?
Yes.
I think that's a 1200. It's 3 times 400 is what I did there.
Is you.
One of those is not in our domain, so we won't even use it. Let's make sure the other one's in the domain. Is 1200 divided by square root of 91, is that between 0 and 600?
Yeah, I'll say so.
I hope so, but it might not be. It's not a guarantee. You can find critical values outside your domain. So it is, okay, so it is between 0 and 600. So all we have to do now is we have to evaluate the endpoints and the critical. This time the endpoints are actual hard endpoints so I can evaluate them. I don't have to do limits this time. So I have to do the time at 0, time at 0. I have to do the time at 600. And then I have to do the time at whatever that is, 1200 over root 91. Question?
What? Oh yeah, you should probably tell me.
Oh, good question. I forgot a whole step. Joe said, well, wait a minute, time out. Well, did t prime equals 0? What about t prime equals does not exist? You're right. Let's back up a minute. It means it does not exist. When the denominator is 0, so that would be 30 radical x squared plus 400 squared equals 0. How do we solve that? Poor John, he's taking on water. He's going down now. Let's solve it, folks. Just an algebra question. How do we solve that? Maybe divide by 30 and square both sides. Okay, so that's going to be x squared plus 400 squared equals 0 divided by 30 squared, which is 0. So then x squared equals negative 400 squared. Say what? X equals plus minus square root negative 400 squared equals complex.
It's a non-real answer.
You can't do that.
It's not in domain.
Wait,
Is that true?
Right? Square root of negative is complex, folks. There's no answers here. So this isn't going to help or hurt us. It's NA. It's not real.
Yep.
Is this the one who starts with fraction function will not have?
Follow? You subtract 400 squared to the other side, you get a negative. I think I did that right. Am I off? 5 by 30, square both sides, subtract 400 squared, take the square root. Yeah, that's complex. Okay, so now we get to testing. So now we're going to test out, we're going to endpoints t of 0, t of 600, and t of the critical 1200 over root 91. So it's got to plug in some numbers, calculate. So I go back to the original function, t, not the derivative, the original function. So if 0 is x is 0, then I got 600 over 10. 600 over 10, which is 60, plus x is 0, then I got the square root of 400 squared, which is 400, so 400 over 3. So whatever that is, 60 plus 400 over 3 is what? $191? 193.3 like that?
Yeah.
Time is 600. That's going to be a 0. 0 plus. Then I got to do 600 squared plus 400 squared. Square root. Divided by 3. Square root of 600 squared. That's 36 with 4 zeros. So what's that? 36,000? 36,000? Whatever, y'all calculate. Divided by 3. What do you get? 240 point what? 37 seconds. So let's think about it. The analogy T of 1200 over root 91.
Okay, Joe. We're at 58,766.
That's not right, right?
How much? 58,000.
Yeah, that's how long it'll take, right?
That's how long it's taking us to calculate this number.
That's pretty.
97.19, so we'll make it a 0.2. That sounds more reasonable.
Well, you know,
So it doesn't save a lot to, on this case, it didn't save a lot to dive in, but it did save 6 seconds.
oh, genius.
Right, if she ran all the way to perpendicular and then swam, it was going to take her 6 seconds more than if she ran that far from. So what? That's a feat, I guess. So let's answer the question. Okay, let's go back over here and answer the question. So, the minimum time is 187.2 seconds if Susie runs to a point about what is 1200 over root 91?
125-ish.
About 125-ish.
5.8
Yeah.
5.8 feet. From the perpendicular spot. That's actually curiously pretty. The gut feel for most lifeguards is about 2/3, maybe a little more than 2/3 of the way you run, and then you swim. And that numbers came out pretty close.
It's pretty cool.
Okay, that was another good example, I think. So now my question to you: did you try any for homework that you want to go over?
I was supposed to know that.
Just pick one in there and go over it. I'm gonna say that was probably a yes. Well, actually, it was a no, then a yes.
And so things just take forever, dude. Especially the polls.
But Lisa was doing something.
Oh no, he didn't do them.
I did not like 41.
He didn't even do his running example. So I
I
just
know,
cut it
I
out.
saw that.
I just cut it
Okay,
out.
so 31 and 41.
Look at what I have now.
Can we do?
Mm.
Can we do
Yes.
31 and then 41?
If we have time.
31 and then what?
41.
31 and 41. Okay, let's look at 31 and 41. 31. There's 31. Find the point on the graph of a function f that is closest to the point AB by minimizing the square of the distance from the graph to the point.
Let me have it.
Just a little bit.
I'm just watching. They have so much initiative.
So what was my function on, this is number 31, what was my function?
3 plus 1.
X plus 1, good. What was the point? Negative 1. All right. Okay, so we're supposed to minimize the square of the distance. So, is that what it said?
Yes.
Find the point, the
Yes.
nearest point on the graph. So, graphically, let's understand a little bit first what we're doing. Then we'll attack the problem real quick. So, 3x plus 1 is a line through 1 with a slope of b. So maybe like something like that.
Pretty steep.
F of x. And then we're given some point not on the line, negative 2, 1. So maybe about right there.
Mm-hmm.
And we want to minimize the distance. So the idea basically is from algebra and geometry, the distance that's the minimum is if you go straight to it. So if I have a perpendicular line, I can figure it out that way, folks. But I'm not going to go that route. I'm going to use calculus. And I want to figure out this point right there that's closest to, the point on the line that's closest to the given point. So, objective is to minimize the square of distance. I guess our subject to constraints are going to be the equation, given equation, a point. I'll have to think about the domain in a minute. Let's see if we can get our objective function that we want to. We want to minimize the square of distance. So let's start with what is the square of distance? So distance squared what?
RT squared. Or is it RT squared?
Sure. A plus B squared. A squared plus B squared. That's right.
Yeah,
so
that's right.
A squared plus B squared is right.
Yep. Got it.
You learned this formula is square root of x2 minus x1, all that stuff. Well, that's just the Pythagorean theorem. So if we square both sides, we can make the square root. So we're going to have, you might think like this, x2 minus x1 squared, and y2 minus y1 squared.
I like
okay.
that.
Well, let's say that this point, this green point that I've identified, let's identify it as x comma f of x. That's on my function, x comma f of x. And the point not on the function graph is at negative 2, 1. Agreed? So now in my equation, my objective equation, I can say that maybe x2 could be my x. So I'll use the green to match that up. So there's x. And then my x1 would be negative 2. And then y2 could be f of x. And then y1 is 1. But I have an equation, folks, and I've got it down to how many variables do you see here?
2.
X and y. But the y here is f of x. So I already know what f of x is, so I can replace it. So d squared equals x plus 2 squared plus 3x plus 1 minus 1 x squared.
That's pretty awesome.
Now it's a single variable. It's a simple calculus question. I can clean this up in several different ways. At a minimum, I would do this. You could, if you wanted, distribute it out and combine like terms. I mean, maybe that's the easiest thing to do. I mean, that's fine, whatever. So d squared is equal to 9x squared plus x squared is 10x squared. Plus 4x plus 4. So at this stage, it's now a function of a single variable, so we can even write it as d squared of x. And the rest is fairly simple. I mean, taking the derivative, that's easy, and so on. But let's look at the domain. What's our domain of x values? Yeah, this x value could be way down here somewhere, or it could be way over there somewhere. So my domain is, at least theoretically, negative infinity. It's clearly not going to be that far away, but that's the only constraint on it is infinity to infinity. Can we finish this now? Or, I mean, do you know how to finish this? I mean, I'm going to guess when you check the endpoints and you do limit x goes to negative infinity. So if x goes to negative infinity, I'm going to say that this distance is going to go to infinity.
You think so?
And if x goes to positive infinity, then probably that distance is going to go to infinity. So the minimum distance is going to be at the critical value that you find from here, which should be easy because it's polynomial. Clear on this, everyone? I need to finish this before we move to the next problem.
Can you finish it?
Do you need those?
Do we feel we can finish it now?
Yes.
I don't know if we can finish it on our own. It's a thumbs up, okay? Good. Okay, so we'll move on to the next problem.
I did not approve.
I got several thumbs up. No one said no, so I'm going to move on.
I said no. My electoral power has been used against me.
Okay, the next one was 41.
41.
Okay, so we're supposed to directions. Find the directions. 39 through 42. Directions. You are in charge of constructing a zoo habitat for prairie dogs with the requirement that the habitat must enclose 2,500 square feet of area and use as little border fencing as possible. For each of the habitat designs, describe find the amount of border fencing that the project will require. So let's see, 41. I'm gonna start with what do we know before I even do anything else. What's my objective here? So this is number 41. What's my objective? Set in the directions.
Prairie space. Maximize.
Minimize the fencing. So we want to minimize fencing. But we had a constraint. What was the constraint that was given in the directions? Must maintain an area equal to 2,500 square feet. And then we would have to figure out some kind of domain. The rest of it is just based on the geometry of the figure. So we're given in number 41, let's see, a trapezoid-shaped habitat whose angled side is an enclosed walkway for 2 patrons, so that no fencing is needed along the walkway. Where the walkway makes an angle 60 degrees with the right fence, as shown in the next picture on the left. So my habitat picture looks something like this. And this is a walkway, so I don't need a fence there, but this is 60 degrees. There we go. So I need that to be 2,500 square feet, and I want to use the least amount of fencing possible to do so. Well, let's start writing an equation. If I'm trying to minimize fencing, what's my equation going to look like?
Perimeter.
So instead of cost or time, we're now measuring fence, right? So we need some kind of function. We're looking for some kind of function, fencing, as a function of maybe whatever variable. Let's call it x for now. So now we just got to figure out fencing. Okay, so how much fencing do I have?
Yeah.
Well, we need an x in here somewhere. Let's call. Do they label an x? I mean, I was just going to make up one if they didn't label it. Okay, good. That's good. We'll call that x. Huh. Let's call that y and that z. So how much fencing do I need?
Dang.
X plus y plus z. Would y'all agree with that?
Yeah.
How many variables do I have there? 3. That's too many. So we got to get rid of some. Let's start by maybe figuring out how to relate y and z together.
Make a triangle.
I don't know if that's possible. I don't know. Maybe it's not. Yeah, this would now have to be 30 degrees because of what I've drawn there. Okay.
That's pretty good.
Good. So then, how long is, so this whole thing, I said this whole thing here was z. That's what I just did a moment ago. Well, that means this amount is y, that amount is also x. So how big is that side right there? Well, it's z minus y, but how else is it? It's right triangle. I'm going with that. That's the way we go. Oh no. What did it say how long that walkway was? Did it say? Oh man.
We're doomed.
I'm thinking it could be related to this side x and 30 degrees. Maybe somehow. I'm asking about this. We'll call this dimension W. Can you figure out W now?
Yes.
So what is it? Tangent of 30 degrees equals W over X or something like that?
Mm-hmm.
W equals X times tangent of 30 degrees. If that's W, and Z is equal to X, not X, Y plus W, then Z is equal to Y plus X tangent of 30 degrees. That's nice, because now we've got our fence equation down to X plus Y plus y plus x times tangent of 30 degrees. Huh. That was nice. I've got it down to 2 variables now. But I still got 1 too many. Huh. What haven't we used yet? What information have we not used yet? The area is 2,500 square feet. Well, there's some relationship between area and x, y, and z in here.
Mm-hmm. There's no z anymore.
What is the area of a trapezoid? Anybody remember that? Well, if you have a trapezoid, it can be seen as a kind of unusually shaped rectangle if you wanted. If you found the middle line of it like this, and then formed a rectangle,
Oh my god.
you see that the rectangle is the same area as the trapezoid, because you've got a little extra there in that rectangle that's compensated by the little extra right there. So the area of the rectangle is the same as the area of the trapezoid. Huh. So all I got to do then is multiply this height right here times this base here. But that base is the halfway. That means it's the average of this base and that base of the trapezoid. So it's just like 1/2 of, and we'll call it base 1 and base 2. So 1/2 of base 1 plus base 2 times the height. So if I use that with 2,500 square feet, then I have 2,500 equals 1/2 of base 1 plus base 2 times height. But now in this picture over here, my height is really x my base 1 is really y, and my base 2 is z.
Oh wow. Well.
So maybe I didn't have to do all of that right there. I just did. I see another way I can handle it. I could solve this for y plus z. So y plus z is equal to 5,000 divided by x. So instead of doing the substitution I did a minute ago and got it down to 2 variables, I could go straight to 1 variable by using this. So I'm just going to kind of strike that out and say, well, instead, I'm going to have x plus, and y plus z right there says it's 5,000 over x.
That's nice.
This is my function of, and the last thing we need is a domain, and then you can take derivatives and finish it. Any questions on finding that? So I tried one thing, wasn't getting very far using trigonometry, and then I said, well, what else do we have up here? We've got area, and so we use the area equation for a trapezoid to get down to 1 variable very quickly. That was nice. Now we need a domain of that function. Yeah. So what's my domain? Yeah, you could parentheses 0, because you really couldn't have a 0 dimension, but in some sense, and you can't actually even use it in theory because it's divided by 0. And the other end of it would be, what's the maximum x to be? I guess, I don't know. Yes, it could be. It couldn't be infinity, because you've got a triangle. X. If I make X as big as it's possible, then I can shrink everything up to here. I'm not going to have just a flat rectangle. So you're always going to have some kind of triangle, 30 degrees here, and X there, and some kind of number here, W. But that area has to be 2,500, so 2,500 has to equal 1/2 of X times W.
I like that.
Oh, I don't know. What is W again? Right. X times tangent squared. You don't have it somewhere. So 1/2 X times tangent 30. So if I solve that, I can figure out what my X max would be, I think. So you can have like X squared equals 5,000 over tangent 30 degrees. X equals the square root of that. I think that's going to be your maximum of X. And that, what that does is it puts all of the, I guess you could actually include that one. That's how I'm intended. So that's going to put all of the area in a triangle. It's not really a trapezoid, so it's kind of not achieving what they wanted. But there is some in, because there's always going to be some area up here. So anyways, I guess we're out of time. So there you go. There's another example. You can take the derivative fairly easily of this function and then use the endpoints and critical to determine the minimum amount of things. So tomorrow is Monday. We'll hit the next section.
Yes, tomorrow.
Pardon me?
Tomorrow is Monday.
Tomorrow is Monday. We'll hit section 5. Go ahead and finish these up. Maybe you can go ahead and read ahead on section 5. We've got to get those done for our test on. Now, Davidson, aren't you out on Tuesday? Yeah. Our test is scheduled for Wednesday next week. We have Monday and Tuesday to cover this next section. So we'll cover it on Monday and finish up on Tuesday and have a test on Wednesday.
Are you going to
Amanda, are you going to be there on Tuesday? Or is your class going to be there or not?
We'll be here. Because we were sitting there.
We'll be there.
They will be there.
They will be there. Okay, fantastic.
I don't know everyone's name, so this is
Claire.
I'll like swat it around the whole floor, and then I'll like do it, and Mom's just like, what that
I was hoping everyone would like it. I wanted to do something cool with SGA, because last year, I'm the only member on there now that was there last year. But SGA didn't really do much. Like, we did the semi-formal and some stair week stuff, but that was it.
Yeah.
And if you were to ask anyone, they would be like, oh, we're having SGA.
Yeah.
So I wanted to do something, like, we're handing out stuff every day except Monday.
Did you read 43?
Because on Monday, it was just kind of, you know,
I read it.
we had a meeting that day. I know
Are
Friday.
you guys saying,
It's Twin Day, or
Duplicity.
I guess.
yeah.
And so we're handing out double mint.
Oh, cool.
You're handing out what?
Double mint.
Well, that's pretty awesome, dude.
So we were trying to do something special. But people know SGA. I like it. I think we should do more stuff, but it's hard because I don't know how much we can do. We don't have a whole lot of money.
Yeah.
No class.
Plus,
The
Yeah.
no Sammy, that's why robotics is cleaning the football stadium tomorrow.
Oh yeah,
but it's like with SGA,
the best.
I love my SGA people.
For it.
Yeah.
And they're very hard working in the meetings and stuff. But like, if everyone's assignments to do, nobody does them.
Where is it?
So like, for the trick or treat thing we had, did you go to that?